Finally, I want to end up this lecture by giving the estimation on the parameters of the subfield subcode or the trace code. Or given FQ to the M linear code C of length. And so the length, their length are going to be the same, has the same length of the initial code by their construction, by their definition. And for the dimension, first we can give upper bounds. For instance, when we consider the subfield subcode of C, its dimension over FQ is going to be less than or equal to dimension of C over FQ to the M. Indeed, in order to see that, it will be enough to observe any linearly independent vectors in the structure which are linearly independent over FQ are also going to be linearly independent over FQ to the M. Similarly, for the trace code of a given linear code C, we have observed that traces onto. So if you consider the definition of the trace function, by extending the definition of the trace to n-dimensional vector space over FQ to the M, we can easily say that trace function behaves surjective on trace code, and this is also FQ linear. So this is why dimension of the trace is less than or equal to dimension of C over FQ to the M. So this is going to be M times dimension C over FQ. And similarly, we can also give lower bounds for the dimension. For the subfield subcode, in this case, for the lower ones, we are going to use the Delsart theorem, which allows us to associate the dual of the subfield subcode of C with trace of its dual. So if you consider this equality, in this case, the dimension of subfield subcode C indeed is going to be dimension of the dual of the trace code to dual of C. By Delsart. And if you consider the definition of the dual, the definition of the dimension of the dual code, indeed this dimension is equal to the dimension of the whole space, ambient space, minus the dimension of trace code of C dual. And due to the upper bound for the trace code, let me denote it by double star. We know that the dimension of the trace is bounded above n times dimension C. So that means this quantity is bigger than or equal to n minus m times dimension C diyor. And if we apply again, if you consider the definition of the CDU, what we get is n minus dimension C over FQ to the M. Indeed, if we consider its dimension over M, we can write it M times dimension C. And indeed, we want to see that if we write this expression explicitly, plus M square dimension C, indeed we can see that this is bigger than or equal to dimension C minus M minus 1 n times dimension C. For the last equality too, in order to check the last equality, let me denote the dimension by C, and indeed what we want to verify is that this quantity is bigger than or equal to T minus Mn Mt plus T minus N. Indeed, this is going to be T minus Mn plus Mt minus T plus N. Mn M square T. So if we also cancel these quantities, we can also always see that the M square T is bigger than or equal to Mt, and in this and then we can verify this last inequality. And similarly for the dimension of the trace code, by using the Delsart's theorem, we can replace this trace code by the dual of the subfield subcode of the dual of C. Indeed, it's going to be n minus the dimension of the subfield subcode of the CDU. And again, by using this upper bound, we can argue that this quantity is bigger than or equal to n minus dimension C dual. In this case, it's going to be dimension over. This is dimension over FQ, this is dimension over FQ to the M. And indeed, by the definition of the dimension of the dual, this is nothing but the dimension of C over FQ to the M. However, minimum distance or in general weight of a linear code is not going to be as many for subfield subcodes and the trace codes. And this is why at the first glance, it's not going to be easy to give an estimation for the minimum distance for BCH and the group codes. And for this purpose, we need to use advanced tools, and particularly our, from the next week, our main text will be to understand the dual of an algebraic geometry code in terms of with some related but new notions from function fields. And indeed, we will see that the AG code, as we have constructed as the evaluation, is not going to be on the constructions from the algebraic function fields.